Here are the properties of definite integrals. Now, for the most part, when you're doing a question, this doesn't come up, although there are sometimes specific questions surrounding just the properties that these things do come up. So, some easy ones. If you're integrating from A to A, it's 0, because you're not actually finding enough space to have an area. That should make sense. Okay? If you're going from A to B, that's the same as the negative of going from B to A. Which, if you think of one area minus the other area, if you did it in the opposite direction, it would make sense that it would become negative. If you want to put a value in between A and B, then the area from A to B is the same as the area from A to C, and then adding the area from C to B. Because you're just splitting it up into two different sections. Number 4, and we saw this with integrals already, anytime you're multiplying some function by a constant, you could pull that constant out in front. Do the integral by itself. You could do the definite integral by itself and just multiply by that value in front. Okay? How does that work? Well, it has to do with what, if you think of the k as a vertical stretch, stretching your value up, it's going to stretch your area up by 4. So whether you find the small area and multiply by 4, or multiply it by 4 first and find the area, won't make a difference. And we know that you can add or subtract functions and find them separately, or do them all together. So.
Do we have practice time?
No. Well, maybe at the end of the class, because we'll see how long this takes. So now, we're still talking about area under a curve with the definite integral, but now we're looking at what happens if we're trying to find the area under the curve bounded by the x-axis. And so sometimes that area is going to be above the x-axis, sometimes that area is going to be below the x-axis. And when area is below the x-axis, the definite integral comes up with a negative answer. But if you're actually trying to find the area bounded between the curve and the x-axis, you're going to have to deal with the fact that some of it's negative and some of it's positive. So here's one that we've done already, 2x minus 1. Here's minus 1, slope of 2, run of 1. Here we have our line, and we want to find it between x equals 1, 2, 3, 4, 5. 1 and 5. Take out our fancy crayons. This one looks nice today. It's just so enjoyable. Sometimes it takes longer to color than. I know those two lines, they bug me. I know. It's just like, so that's why I started going darker to try and get rid of those. But they don't go away.
We have time to redo it, Mr. Ross. Take your time.
Right. So there's a little bit of disappointment showing through there. Oh, and then I shaded too much. Oh.
That's cheating. We don't have that.
There's also like you don't have an eraser?
No, well, you got to erase.
Following the road.
Kind of can. You just.
It doesn't work great, but it do.
All right. Is that better? How are we feeling? A little bit neutral. Okay. So there's our sketch. In this situation, none of it is below the x-axis. So when we integrate this one from 1 to 5, 2x minus 1, put our square brackets, put 5 and 1, x squared minus x, (25) minus 5, 1 minus 1 is just 20. So that area is 20. And we did this already last class. There's nothing new in this one. But there's something that is interesting that happens is that you can see in our second one, how come the area from 1 to 0 was 0? Because that's what this appears when I simplify it. And the reason that shows up as 0 is because we have an equal amount above and below, and the definite integral will consider the top part positive, the bottom part negative, and they cancel each other out. Hence, we get 0 for what we're subtracting. Find the area enclosed by the curve y equals 15 minus 2x squared, the x-axis and the lines x equals negative 2 and x equals 2. So the reason it's nice to start by drawing a sketch, okay, negative 2x squared plus 15, that would have a vertex at 0, 15. It would be a parabola that goes down, but what I'm really concerned about is where are these x-intercepts? Is my negative 2 and my 2 going to go beyond them, or is it going to be constrained within them? So if I wanted to find those x-intercepts, I could set my equation equal to 0. What's the square root of 7.5? 2.7. So we would have on our graph negative 2.7 here and 2.7 there. So if I was finding between negative 2 and 2, and we're going to demonstrate some learning. My coloring is much more enjoyable on the eyes.
Oh, I see a dark spot now.
Has to be one motion.
Kind of has to be. No, I think this is working.
When you see dark spots, I see the dark spots now. I'm enjoying what it's more.
There we go. Oh, feels pretty good right now. Oh, much happier students than the last example. Okay.
The parabola's not perfect. It's switchable.
Okay. So now if we want to integrate this 15 minus 2x squared dx between negative 2 and 2, we don't have to worry about any parts being negative. So we can just go straight to our square brackets. Negative 2 and 2, we're going to get 15x minus 2x cubed divided by 3. Plug in 2, 30 minus 16 over 3. Plug in negative 2, negative 30 plus 16 over 3.
Look at those two 16s over 3 cancel each other.
What's that?
Wouldn't it be just 16?
Oh, it's 2, not 3.
Good. And now if we're subtracting, we're going to get 60 minus 32 over 3, which simplifies to 180 minus that, 148 over 3. Good?
Yes.
So, again, pretty cool that we could find that area relatively easily just using integration. Ooh, this one's going to be pretty. Cos x plus 1. So what is cos x plus 1? Well, if I was graphing cos, that would mean that I would have a maximum of 2, a minimum of 0. If you wanted put in a sinusoidal axis, you could. We're only wanting to graph it between 0 and pi. Well, cos has a period of 2 pi. Cos starts at a maximum, then goes to your center line, then down to your minimum. There's the cos graph, and we're wanting to find the area between 0 and pi. Take out our beautiful crayon. I think this one deserves some purple. I know I'm trying hard not to breathe.
It's actually, I said very enjoyable color.
Oh,
That's over.
that's pretty.
You can't keep within the lines, that's disappointing. Neither can I.
Isn't that nice? Just. I wouldn't poster that. Feels good.
Can we spend a whole class just actually go out, get some actual crayons, and see if we draw the best?
But it's amazing how with crayons, if you start to go in multiple different directions, how it can ruin it, and yet if you go, just feels nice.
I feel confident just looking at it.
Okay.
Can you do that for your math project?
Nothing is below the axis. We have an x-intercept at pi, but that's not going to cause a problem. We want to find the integral from 0 to pi of cos x plus 1. Integral of cos is positive or negative sign? Positive sign. Plus x. Set up our brackets. Plug in pi. I'll plug it in and do the mental math right away. What is sine of pi? What is pi? Nice. Minus, what is sine of 0? 0. Plus, plug in 0, 0.
What side is 0?
It's actually pi.
And the answer is pi, which is really cool.
So I'm guessing if you went to 2 lengths, it would be 2 pi then?
So if you went to 2 pi, it's 2 pi.
Now, my question for you is, how could you have just looked at the beautiful purple drawing that I've done and right away said, I can see that the area is pi?
Because if you look above where the line is above the sinusoidal, you just kind of flip that over. No, that sounds stupid.
Look
But
at it.
No, that's, I think I like,
You're a circle.
because it's a circle. These are circles. You get 0.
Yeah, I guess you'd be like,
Yeah, so what Peter's saying is if I take this, right?
so what? You don't even know the area.
No, I don't know the area of that, but he says rotate it, slide it into there.
Pretty close.
You get a rectangle. That's a 1 by pi rectangle. What's the area of a 1 by pi rectangle? Pi. Pretty cool. Okay? But, I don't know, that kind of ruins it because it was pretty cool that we did integration to find that.
no, this makes it easier.
That makes it easier, but not all things nicely rotate and fall into place like that. Yeah.
If it was just cos x, it'd be 0, right?
If it was just cos x, it would be translated down, and then those two parts, there'd be this part here, which would be negative, and this part here, which would have been positive, and they would have canceled each other out, and it would be 0.
So then how would you find the absolute value of the area?
Then you would have to do your integration separately from 0 to pi over 2. Figure that one out, and pi over 2 to 0. And we're going to figure that out next. So far, all of our examples have had areas that are above the x-axis. Okay? But if you have a function which is negative and continuous. In other words, the function is below the x-axis, and you're finding the area between that curve and the x-axis, the area is going to be negative. And so you need to do the absolute value of that area. So find the area enclosed by the line y equals 2x minus 1. We did this one earlier. It's our first disaster in coloring. Okay? Between -4 and -1.
Wait, this is going in the video?
I don't think you can hear it, Bert.
Thank goodness.
So you definitely can't. Kill Peter, kill Peter.
Oh, you get too excited about coloring, don't take your time, and it's just not.
It's so bad. I like the purple better.
Yeah, purple's much better.
And there was a red dotted line. Oh my god, just stop.
Hey, you made a mistake.
Oh no. Just sign your name on it. Look at that cross hashing.
It's alright.
All right.
Help, we're trapped. Help.
A little bit of anger management. There we go. Okay. So if we find the integral from -4 to -1, okay, of 2x minus 1, we're going to get x squared minus x -4 to -1. Plugging things in here, okay, this will give us 1 plus 1 minus 16 plus 4. We'll get 2 minus 20, which is -18. So I did all the math without any absolute value bars, and I got a negative area, which makes sense because that area is below the x-axis. But the question is asking us to find the area enclosed by this line in the x-axis. That area that's there, that's a positive area. So what we can do afterwards is like go, oh, that was supposed to be positive. So I can add absolute value bars here, add absolute value bars there, add absolute value bars here, add absolute value bars there, and then say the answer is 18. I just did. What do you mean I can't just do that?
Area enclosed by the line, is that like the wording that needs to be set?
Area enclosed by the lines. Find the area enclosed by the line y equals 2x minus 1, these two vertical lines, and the x-axis.
Isn't that what's happening even though?
No, because then it could be positive just because it's just an area.
It's just an area, right? Like, what's the area of this circle? It's not negative because I drew it below the x-axis.
Why do we get a negative value?
The definite integral, when you just do the definite integral, it differentiates whether something is above or below.
And shouldn't all area under the curve then be positive?
Well, all questions that are asking for the area will be positive, which is different than asking for the definite integral. The definite integral is a negative answer to this. It's -18. The area is +18.
Why is -1?
What's that?
If you go back to that thing,
Yeah.
like the B is -1, the A is -1.
The b is -1.
Yeah, your little,
Here and here.
yeah, those ones, yeah.
Well, we're at left.
Mess us up, it messes everything up.
Yeah, if you switch them around,
Entirely ruined.
okay, it does entirely ruin it. The way that
I did do that.
Actually, you'd get positive 18.
left to right, as far as putting your values in.
You'd get the right
Okay.
answer without doing.
So when we are over here, everything makes sense because we're dealing with positive numbers. Here, you kind of wanted to put the 4 on top because it looks bigger. And then you get a positive value. You get the right answer by... Because remember, if you flip these, that's like putting a negative out in front. That was one of the properties. So that's why the answer came out as positive 18. But when we're putting it into our definite integral, we'll go from left to right. So if you have a function which is both positive and negative and continuous on an interval, then the area between the curve and the x-axis has to be done in 2 separate parts. Because if you do it all at once, your definite integral will calculate things and cancel things out without you knowing it. And so you have to find the x-intercepts in between, break up your interval into 2 parts. One of those parts you'll have to do the absolute value of. The other part you can leave the same. If you have no idea which one you want to do, you can put absolute value bars around everything, I guess. Wouldn't make a difference.
These can't be done with calculators?
They can be, but you still have to find your x-intercept and do them in separate parts.
Can't be done all at once.
Not all at once. So, what do we have to do? We have to find all of our x-intercepts. We have to separate the integrals into the sections which include those x-intercepts and solve each one separately by making all the areas positive by using absolute values in the negative sections. And this is where all of your graphing skills that you have so far become really important. To be able to sketch that graph first, to get a sense of what's above, what's below, what do I need to do, is really helpful. So, x squared plus 4x So how quickly can we graph x squared plus 4x?
We can factor out it. You know,
You can factor out an x, good.
x is at 0 and negative 4.
Good. So we got 1, 2, 3, 4, one x-intercept at negative 4, one x-intercept at 4. Which way does this parabola go? It opens up. So if we're drawing a quick sketch of it, this is what we have. And we want to find the area between negative 2 and 2. So getting out our coloring, we need some happier colors here.
Green.
Ooh, let's go that one. Let's try that one. Ooh, that looks like this is filled with water.
We go and put in green. Oh, you can't have water.
Ice. Whew. This one's a cool question.
It's water.
Can you add a bit of pollution and just a bit of gray?
That's the area we want to find. The problem is if we do the definite integral from negative 2 to 2, some of those positive areas and negative areas will cancel out. So when we set up this equation, we'll need to find it from negative 2 to 0 of x squared plus 4x dx. And then we'll add from 0 to 2 of x squared plus 4x dx. And since this is the one that's negative, we'll put absolute value bars around that one. So sometimes these questions become long just because we're going to have x cubed over 3 plus 4x squared over 2 from negative 2 to 0 plus the same thing, x cubed over 3 plus, I'll simplify this time, from 0 to 2. Yep.
Do you have to put absolute value bars if you, what if I just switch the bounds, take it from 0 to negative 2, then that would be a negative, and then it would also multiply.
And if you showed that work, right, you'd show that this is a negative number, right? And the absolute value bar, you know that it's negative, and you're going to switch the bounds from 0 to negative 2 and put a negative in front. That would work out to the same thing. Well, you'd have to make some sort of note showing you that you were going to do that. Some kind of note off to the side. Yeah. This answer, this area is negative. Make it positive by multiplying by a -1. The nice thing about having a 0 in here, okay? Plug in 0. Plug in your -2. -8/3 plus 16. 8. These are the ones with the absolute value.
Shouldn't you go from -2 to 0?
But you plug in the top one first minus the bottom one. Gets so confusing once you switch the numbers around, right?
It does, I understand.
Yeah. So over here on this one, we'll have plug in 2. So what do we get? We're going to get 24/3, 16/3, -16/3. This one, after the absolute value, will be positive 16/3. And over here, 24 plus 8 be 32/3. 48/3. Nicely simplifies to an area of 60. Did I make any mental math errors here?
It's good. What I did is I just took one of them and stick to the script. I took 8/3 plus 8, multiplied everything by 2. That's the same thing as the other side.
I'm just gonna do what you did.
Yeah, it's a lot.
You have to simplify first before you absolute value, right?
You made a mistake.
It's not even 18. It's not even 7.
Young blood trying to disrupt the math.
Send it back to grade 11.
Do you have your math license?
Mr. Jerry.
My math license.
I wrote this in my copy.
So you will, hopefully. I hope you do well, Ramsey.
You're right, so you'll pass.
Good luck.
Well, I wish you good luck. I don't know about Gabe.
You do know Gabe. He said he doesn't.
Let's use your grade 12 skills for graphing this, not your calculus skills for graphing. Okay?
Wait, I think I'm next, right?
Your grade 12 skills for graphing this would know that it's an x cubed graph and have the shape in mind. And you would find, since we need x-intercepts anyways, you would factor this completely. So when it's factored completely, we know that we have an x-intercept at 0, an x-intercept at 1, an x-intercept of 2. And for an area question, do you need to know where the max or the min values are? No. But you do need to know whether this is going up from left to right or it's coming down from left to right. And because it's a positive x cubed graph, it looks like this. Now we want to find the area between 0 and 3. And get out our crayon. We have a request for gray.
Don't you ever eat crayon?
No, it's pretty good.
Great.
The gray looks quite nice. I like the gray, although I feel that this little bit of white space is not making me happy. There we go. That's much better. The gray looks good on the smartboard. On the screen, even better.
Does it?
Yeah, it's like more silvery. It makes me think I'm making money. It's good.
How many quarters do you make? How many quarters do you make?
Yeah, every end of the week, we're going home with our backpacks full of quarters.
That means if you stop by one of those gumball machines, you're gonna empty it. Just take a quarter.
Well, it's just a week's cash. Like quarters are pretty small. I feel like a backpack. But
If you had them in the rolls.
The roll of $10, it's not that big.
Well, what you do is you calculate the area that the roll takes up and figure out how much area.
disclosed.
Well, this is not.
Even an undisclosed amount.
That's the one I wanted.
A disclosed amount, so he's gonna tell us. He's already told us.
Okay, so 0 to 1 of x cubed minus 3x squared plus 2x dx. Okay? And now I'm going to do something because I'm feeling that I'm going to be annoyed. Which, in these questions, you might start to get that feeling. Oops. I got a little bit crazy here. This dx. Okay? Plus, we're going to go from 1 to 2, because if I label things here 0, 1, 2, 3, we have to break this integral up into 3 sections. Does that make sense?
Yes.
Can you see that this notation is true, but it'll save me some time? Right?
I do too. I feel smart.
I mean, I guess, but like, what do you
Just
got
what you do. You just define.
I put absolute values around that section.
Or if you're Ramsey, you'll actually do a switch of it. Right, you set out every time. Yeah, just write it all out. You're still gonna have to. Yes,
So cynical.
Is there something to do with this one?
That's cheating.
Let dot dot dot.
Let dot dot dot.
Nothing, Gabe. Nothing. I can't see.
Someone's gonna rewatch the video and be like, what the hell?
As long as no one hears my cry for help, we're fine.
And have to remember this part is in absolute values. Things get a little bit large at this point, right? Because what do you have to do? You have to subtract. So there's going to be one set of brackets minus another set of brackets plus absolute value. One set of brackets minus another set of brackets. Absolute value plus, uh-oh. Okay. But you're going to get some things repeating themselves. So first of all, you're going to plug in 1. Well, this isn't actually too bad. 1/4 minus, oh, I should have shrunk it this way a little bit. Minus 1 plus 1. Oh, I'll make it. Oh, I barely had enough room for this. Minus. Phew. Yeah, I wouldn't have needed any room. But this one's going to also be 0. No, wait a minute. 2, we have to plug in 2. We're going to get 16 over 4 minus 8 plus 4. Oh, it's also going to be 0 by luck. But we've already done 1, right? We've already done 1 over here. And so I'm just going to put 1/4 in there because I've already done that. Okay? And then here you have to plug in 3. This is where I really needed the space.
So what you do is you just shrink it and expand that.
Okay, if I plug in 3, do you see that you get 81 over 4 minus 27 plus 9? Okay, good. Got it? Did you, no? Got it?
No, not yet. You got it. Shrink it back. Thank you.
Perfect. And then minus, and we've already figured out 2. What happens when we plugged in 2? What is it equal to? 0. Oh, Riley, sorry.
What?
God. Ooh.
Now I have no idea what's going on. No area. That's so precise.
There we go.
You should select the entire page and just shake it and then make it really small.
So what are we left with? In the first part, we have 1/4. Right? That's 0. 81 over 4
Minus
4.
minus 27 plus 9.
Got it.
In the absolute value, and I'm going to keep the absolute values for now. That will all simplify to negative 1/4. And our final section, we have 81 over 4 minus 18. So plus 81 over 4 minus 18. Okay. So the absolute value is going to make that a positive 1/4.
Let's make it 1/2.
Okay? Okay. So now, what kind of mental math strategy would you do in this situation?
Times by multiplied by 4.
What would you do here? Would you make everything big over 4? Or would you maybe say, do some mental math here, right? This is, how can I do this mental math quickly to say, oh, that's 9 over 4? What did I do?
18 times 4, 81 minus you cheated.
Did I cheated? Yes. That's what I always do, is I always cheat.
Okay, 18.
You could. I found 18 times 4, which is 72.
40, 8 times 4.
40 and 32, 72. Okay, good. You could do that, 81 minus 72, and get 9 over 4. I actually found it easier to think of, well, I knew 80 over 4 was 20. So 20 and a quarter minus 18 and a quarter would give me 2 and a quarter.
Wait, 81 over 4 is what? That's too much.
81 over 4
20 and a quarter.
is 20 and a quarter. And 20 and a quarter minus 18 is 2 and a quarter. Like, I imagine having $20 and a quarter minus $18, I'd have $2 left and still have my quarter. And 2 over a quarter, I change back to an improper fraction.
You could add the quarter to all the other quarters and then 20 minus 18.
Or you could choose a common denominator of 440 and figure it all out with that.
Yes.
Yes.
Where was your common denominator 440?
I just picked a random value that was a multiple of 4. But we get 11 over 4 as our total area. And despite the fact that once we set up our brackets, there was a lot of things that needed to be done, we noticed that some of the calculations are repeated, right? You're going to repeat your calculations of 1 and your calculations of 2. So there's not a lot of work to do there. Plugging in 0 was super easy, so it ended up not being too bad to calculate that total area in the end. There we go. Have some time for some practice.